I'm really glad to have you here. This is going to be a boring presentation, I tell you, so be prepared because it's about artificial intelligence, so there's going to be a lot of mathematics and boring stuff. But I hope you're prepared for it. I mean, it's written there. Okay, so you probably know that artificial intelligence is now everyday life reality, no? And everybody's talking about neural networks and artificial intelligence. I think it's a little bit of stupid language, because probably it will be much better to make clear what it is. So we will discover that this is basically some statistic process, some statistic procedure that we can apply using some new processors and some application in our industrial machine. This speech is the first of two speeches, of course. Today this morning I introduced artificial intelligence concept, and in the afternoon we will talk about predictive maintenance. So now we explain what artificial intelligence is, and in the afternoon we will explain what is it useful for, So that's it. I hope that, I prepared this presentation with the idea that people listening was not artificial intelligence technicians. So is there anybody who is an artificial intelligence technician here? Who is this guy? You are? Okay, great. So I hope that it's not going to be too boring, because the idea is to introduce the concept to, people who are not exactly knowing what it is. That's the aim of the story. So you see many things, You have A11 Bionic chip, Siri, Movidius, which is this thing here, very interesting piece of hardware, anyway. Face recognition, we have Bixby. So we have a lot of artificial intelligence all around, mostly, and we will see what it means, based on cloud computing. Okay, so what happens? I ask something to Bixby send, or to Siri. My voice fingerprint is sent to a sort of a central, it's analyzed, and then I have the result back. Okay. Which is not really so useful in the industry, because when you're building up something, you need to work fast. Okay, so try to imagine, I am controlling a production process, I have to figure out if there is a quality problem. The box passes by, there is a hole in the box, there is a problem, but the picture of the box is taken, the picture goes to a server, the feedback of the server goes back, and in the meantime, I have produced 1,000 boxes and I don't know where the wrong one is. So there is a lot of artificial intelligence, but the point is taking artificial intelligence to the edge of production. And that's what VPUs are all about, basically. You know that artificial intelligence is made by many fields or disciplines. Okay, they are converging, but still we need to consider that they are a bit different from each they have different aspects. So we have computer vision, sound and continuous speech recognition, we have machine learning and deep learning, we have robotics, we are talking a lot about collaborative robots, and at this time Vittorio from C-Vision will tell you about the way of all these technologies are converging to make a fully integrated production plan. So we have automatic vision, basically is something like this. I mean, I have a sort of what we call a classifier, and I can make a program. I made one, very basic, for my phone. So basically, the computer here knows, you see, I am recognized as a human being. Okay, you see? Does it work? I don't know. I'm running a very big risk now. Am I recognized? Yes, okay, great. So how it works, in this telephone there is a BPU, there is an intelligent processor which is able to perform this task very quickly, okay? And then in this application, I will show you something very inexpensive later on. This is quite expensive at the end of the day. It's about, in Italy, it's about 1,200 euros. They have a very, yes, they have a very big margin, you know. but you know, there are much less expensive solution for recognition. I have handmade for you this sample, which is looking ugly, but you will see it works later on. It's quite interesting. So classification, computer vision is related to view something. Consider that computers have, for example, have the possibility to see many signals which we are not able to see. For example, radio signal, infrared, ultraviolet, and so on. Then we have, everybody knows that, you know, speech recognition and sound recognition. You will see that sound recognition is very, very important in predictive maintenance field. Why? Because in order to understand if the machines are working well or they are getting broken, we literally listen to their vibrations. Okay, we have sensors like this one. This is a vibrational sensor. We will see it in the afternoon. You can place this on a machine. This is, you know, retrieving vibration, making spectrum analysis, and then it is finding out if the machine is working or not working. So it is very interesting to consider on an industrial point of view that vibrations are, you know, very, very interesting for predictive maintenance, plant maintenance, and sensor development. Good morning. Welcome. So, how old is this technology? Well, this technology is truly old. Okay, and when I teach these things at my students in the university, I always say that truly, again, neural networks, you know, stupid language. It's something that you need, that they say like this because it has to look very, very mysterious. Reality is that this is a very, very old statistical process, as we will discover in a few minutes. And but why from 70s we have to wait until today in order to use this technology? Because we didn't have calculation power. We need very powerful computer. We need parallel computing in order to make all the little calculation needed for deep learning and artificial intelligence. So, what is deep learning? Anybody here knows what deep learning is? How it works? No. Interested? This is going to be boring, I tell you. Everybody? Are you sure? Okay, I carry on. It's your fault, not mine. Don't complain. Okay, so this is a neuron, you know, and this is supposed to be what human beings use to think. Nowadays, we have more problems with natural stupidity than problems with artificial intelligence, you know, so it means that I always say that I don't know if an imitation of human beings is a very good idea. And that's one point. Neural networks are not really imitating human beings. They have one thing which makes them much better. You can test what is that they are doing before delivering them, which is not happening with humans. Okay? Why do they call them neural networks? Because the shape of the mathematics behind them looks like a neuron if you draw it in a certain way, and that's the only reason. Okay, so consider you may have some inputs. On these inputs, you put some weights, which are some little numbers, okay, that you put there. I will explain later on how to do that. Then you make a sum of these numbers at a certain point, and based on an activation function, which is something very easy, it's a function based on that little number, you deliver a result. So that's it, very easy. You get some numbers on one side, then you make a sort of a pipeline. Okay, you crunch all these numbers, you make all these functions, and then you deliver an output. So if you want to decide, for example, if Andrea there is a human being or not, which is probably not, you get the application on. The telephone gets all the pixels of the picture, and every pixel of the picture is passed through the algorithm. Then this is the procedure, and it decides that probably that is a human being. Okay. So, how does this work? Of course, there are many of these layers, exactly as it happens in a human brain. So you consider that this little function repeats itself in many little layers. Okay, so imagine this structure. You have a sort of an input layer where you put your data. What are the data? For example, the data from industrial machine thermodynamics. So you have, for example, temperature, you have a lot of data. You have speed, you have the kind of production you are making, you have input material. So you make a model of all this input data you want to put in this machine. Okay. Then you have these hidden layers here. There you see hidden layers. This is where the magic happens. You don't exactly know what's inside there. I will explain you later on how it works. But you know, that is able to deliver an output layer. What is an output layer? Is a single result. So, let's say that I take a picture of something, I get all data from a machine, I get vibration. Data are filtered through these functions. Every little ball has a function, an activation function inside. And then the information passes through the next level if the result is delivered from the activation function, if the neuron is activated. Okay? Now the point is, how do you train this thing? You know, that's a neural network. I mean, it's done. It's done. That's all. How do you train these things? Well, I used to say that the governments are experts in artificial intelligence. Why? Because the first thing you do is you put a lot of random numbers inside there. You know, you don't decide anything. You take some numbers and you put them inside, and then you try. You see, you need an history of information. So, for example, you need what your machines are doing for a while. For example, if the machine got broken, what was happening when the machine got broken? What was happening when you had a quality problem, and so on? You know, so you start with your historical data. You put a random number inside the layers, and then you start testing. So, what is that you do? You put data inside the machine, and you tell the machine if the result is wrong or right. That's it, basically. Okay, this is an automated procedure. You can do it automated. Okay, so what you do is, first results are going to be a lot wrong. Then you train. You find out what the error is. For every little ball of little layers, you put this number, okay, and you get the result out. That's it. So, as soon as you have a pattern of number which makes your result correct, which you know that they're pretty, you have an artificial intelligence. You have a neural network classifier. But before you got it, you need to ask her one question. And the question is, you see that I make a mistake, and then I say backward. Okay? I make a mistake, and then I have to say to the machine backward, and I have to change the little weights, the little number I have into the ball in function of that mistake. But we have a lot of hidden balls. Okay, how do I decide who's the fault? Where is the fault? Where is the problem? Well, I told you that a neural network behaves a lot like the Italian government. So the fault is everybody's fault. Okay, there's not a specific ball where you have the fault. You know, something went wrong, everybody, we don't know exactly who's the fault. Everybody's fault, everybody's going to pay taxes. That's it. So what do? We deliver an error function. Okay, this is a typical statistical error function. Okay, and we need, basically, what do we need to do to get our result perfect? We need to take the value of this C to the possible mean, right? What is that we do? Well, you see that this is a square function, you see? So this is going to result into a curve, which is going to look basically like this. I have the slide. I don't know why I'm doing like this, like a video. Well, now, you have the curve here, and you know that the best point is this one. So when you do the training, you need to go into these little balls and then make the training, test everything again, and minimize the C factor. Okay? The first thing that comes up to a simple mind to do this is a brute force. You know, I start calculating everything and then I see all the possibilities. Then I figure out what is the minimum, which is here. But this is a bit of a problem. It has been calculated that using this approach would take about 1 million years to recognize the images of the numbers from 0 to 9. So this is not a good idea, with the most powerful computer in the world. So, wrong way, this is not what we are going to do. What is that we are going to do? We are going to apply another strategy, which is called the gradient dashing. What is the gradient dashing? Instead of calculating all the values, I do figure out what is the tangent angle. Okay, so if the angle goes up, it means that the mistake is very big, as you can see here. As soon as the angle goes down, I am going closer to the solution. So I am just jumping, and jumping. And this is what makes deep learning possible in the reality. And this idea made it possible, made it easy for everything. You know, you can have deep learning on your phones, you can have deep learning everything, just because of this way of calculating the curve, which is not rocket science. Okay, now, I am really sorry. Now, most of you are thinking, well, but I thought that artificial intelligence was intelligent. It doesn't look intelligent, right? So, this is not, I mean, there are a lot of people, there's Mr. Hawking talking about singularities and so on. Well, this is not so close. I mean, the point is, this is what we have today available on the market. This works really, really well, okay? And with this strategy, we can create and deliver intelligent industrial machine and plants in our industries to make a better competition. So, well, I don't care that much if there's no soul inside it. I mean, the point is making money, and that's great. It works very well. You have heard about two words. Somebody's talking about machine learning, somebody's talking about deep learning. The difference between these two technologies is basically, let's say, the difference is basically in the number of hidden layers. So when you talk old machine learning technology has just one hidden layer, okay? New technologies have many hidden layers. Why? Because the calculation power has got stronger and stronger, and now it's quite easy to deliver this power in order to get the result done. And now, here we have a question. I don't know why this slide had problems. I'm sorry for that. I will correct it for the next speech. Probably it's a resolution defect. But the question is, why do we need artificial intelligence? Why do we need that? Well, the point is that artificial intelligence is giving us the possibility to make machines that are able to freeze and distribute frozen knowledge. This is incredible. This is incredible. I used to say to my students that, well, IT people are very lucky. We are very, very lucky. Why? Because we have something that makes us able to deliver our knowledge to our colleagues fast. Okay, we have object-oriented languages. So if I want to deliver something to a colleague of mine, he doesn't even need to know what my function is going to do. He can take the function and put it to its program. This is not really happening in other research fields. Think about it. For example, this is a task that I have accomplished. You see that most research and diagnostic images on microscopes are about finding small little things, I don't know if anybody of you has been in some research, some medical research project, they are looking for these small things inside this image. This is, for example, an image of a frozen fish, and this image has been made to discover if the fish has been correctly frozen before eating. That the fish before eating needs to be frozen at very low temperature. This is what the Italian Institute of Minister uses in order to understand. But the point is, even today, even nowadays, this job, even with computer-assisted procedure, is an early process. They take the pencil. It doesn't matter if it is a real pencil or it's a digital pencil, but what they do is basically take measures, and that's it. So tomorrow, via the machine learning procedure, via artificial intelligence, we'll be able to classify the little particles clicking on them. You click on a particle, the computer tries to figure out and tells you, well, the similar particles are this, and tell me, it's wrong, is it wrong or is it right? And then you make what we call a graph. What is a graph? It is the frozen knowledge of that particle. So if you want to send that particle to a colleague, you take a file, you attach it on email, you send the file, the colleague on the other side of the ocean will go there. Okay, look at the particle, that's it, you can recognize it on your own. This is much faster learning, so this is what the computer looks like. And this has been really a job of mine because with this we have made a patent on it, and this is made really to identify the frozen fish from the unfrozen. It has been quite successful, and that's it. But the point is, human time per image before the process, before the automation, 4 hours. Machine time per image from 2 to 4 seconds. 1 year ago. The computer I have on the back today is going to take 1 second because it's an i9, okay? And because I made the better program, it was a bit of prep first anyway, That's how it works. Other example, automated analysis of plates aggregation process in simulated blood flow. This is very important for oncological research, okay? Because, it takes a lot of time because what do? They take a video of the particles, of the flow, and then they have to analyze each frame. It is 25 frames per second to see the variations, to see how the plates are what is going on, how the aggregation works, and so on. With an automated process, the computer will do that instead of the human. Result, 3 weeks of the human, 3 times for a computer. Okay, so this is what artificial intelligence can do for research in every field. Other example, this is something that I was not able to sort out yet. I believe that I will be able to do that before the end of the year. Right now, I wasn't still able to sort it out completely. It's automated identification of steel structure from SEM image. What does it mean? You have a piece of steel inside the bridge, for example, and you have to know what is the status of this steel. So you go there, you take a scrap of the metal, you go back home, you put it under a SEM microscope, you watch it, and you see what is this structure. Drawing the structure takes days for a human. Machine is much faster. So, I wanted to show you some examples because, they look unexpected, but there are a lot of fields where these technologies may be applied. And wherever you apply these technologies, what you obtain is a much faster and much efficient process. Let's consider what is the, especially medical research today. So somebody has an idea, okay? Then he goes to find some money, basically. Let's figure out that he found the money, which is not so easy, but anyway. Then they go into research, and they stay there, study, write a lot of paper, written. Then one day, finally, maybe when the guy wanted to pay for it, to spend at least a double of what was the main idea at the beginning, they get a result. When they got the result, what do? They write documents, a lot of documents, and then they send the documents to the industry. So I make a patent, I discover something, then I have to deliver this to a pharmaceutical structure to deliver pharmacy, to make it real, to make the people eat something that make them feel better, okay? And this takes a lot of time because write docs, a lot of docs, and then when they go on the other side, there is somebody else who has to read the docs. It takes years. They need to study again, as in the university. They need to start back from the very beginning, read the documents, and I used to say that the world is divided in two groups, okay? The ones which didn't explain them that good, and the ones which didn't understand right. And the point is that they are exchanging every day, they are. So life is complicated, in this way, because I read, I write, I call, but I didn't understand, but it doesn't work, but for me it worked, and so on. You know perfectly what I'm talking about. When this is done, it takes weeks, months, years. They basically, in order to try to understand how it works, they repeat the research from the scratch. They do it again. They start it over, they buy the same instruments, they spend some money, well, of course they know what they need to do, but they have their own interpretation. They start it over again. And then finally they make an engineering process, which means delivering a product. Okay? Look what happens with artificial intelligence powered knowledge share. Well, that's much easier. I have my graph, I have my molecules, I have my whatever. That's done. That's a job done. I take the file, I deliver to the engineer. The engineer doesn't even need to know what this is all about. It just needs to make it happen. So, a very short document, a make it happen document, easy to share, easy to try, because when I have done the result, I have the intelligence of the inventor right in my computer, just being able to test the solution right now, right here. And I will immediately see if it works or if it doesn't work. If the engineering procedure is done or it's not done. And then I go straight forward to application. So this is what artificial intelligence is all about. Artificial intelligence is the best way to fight natural stupidity, as I generally used to say. Consider this. This is an interesting This is an interesting drawing. Unfortunately, sorry. You see, this is a pattern. Okay, what do you see in this pattern? A horse with a cowboy, but it's much clearer when I do like this. Okay, this is generally what we consider pattern recognition. Okay, if you train a machine to recognize something, the machine will be able to recognize that thing even when it is, of course, here it's not so easy. Okay. So, deep learning is mostly about classifying the information patterns. Okay, so you have understood that. I told you, I mean, basically it is like I have my pattern, I have my data, I have my historical data. I can get this data and I can get knowledge out of them, and I can transform this data into what we can call a graph. Okay, graph is a technical name to basically to mean the neural network itself. All these little numbers. Okay, it's very interesting to figure out that when you do this, you can involve multiple signal sources. So identification of specific pattern situation may be easier for machines than for humans. I mean, if, for example, if you have a machine which is based on gases circulation, like like a compressor or something like that. If you listen for ultrasounds, for sounds which are going over 20, let's say 21 kilohertz, then it is possible, it's very easy to detect a failure of that machine, for example. Okay, but the human will not be able to do that. So that's the point, I mean. What is the next thing for industry? The next thing for industry is predictive maintenance. What is predictive maintenance? I go there, I place specific sensors to the machine, I get data from the machine, and then I make an intelligent thing which is able to detect the problem before they happens, and it is able to suggest the solution to the operators. Okay, so this is what we are going to see in the afternoon at 4 o'clock in another room, which I believe is the room number 2. So I hope that you like the thing. Before
Number one.
No, this is number 1.
Number two.
Before we leave, I want to show you something, which is a handmade prototype. I made it for you, unfortunately, because I needed to show you something. This is basically an unuseful screen. This is not useful. This is only useful for demonstration. This is a neural network stick. It's quite impressive. Everybody, it's a market product. It's a very common market. You can buy it on the internet for $80. You can buy the Raspberry Pi, which empowers this machine, for $20. Okay, then I put the stick here. Putting the stick here makes the artificial intelligence, the parallel processors enabled. Then I get the battery. Generally, when I do this show, it doesn't work. So you have to send positive energy to the prototype. Please send positive energy to the prototype. And I started with my cell phone battery. I wanted to put a battery, but Amazon didn't deliver it in time, so I had to use this one, unfortunately. All these things are bought on Amazon Prime. You can go there, get the components, and deliver it. Okay, that's it. And let's say it has to start, it has to get hot. You remember the old machines. In fact, this is a 24-box computer, so it's quite, it's quite slow. It's not fast at all. And the point is that using this processor here, I can deliver a fully functional neural network optical classifier. It will start start. Yes, it's starting. And, it is a monitor, so you can take a look at it, it works. And it is very interesting to know that you see you are humans, there are a lot of humans, you can see, there is a human there, you see, and there is there is a monitor there, you see it's classifying the monitor, you can watch the human here, and well, please, if it gets broken, it's not going to be an incredible loss, so never mind. See? This is classifying things, and it's really, really inexpensive. But what is the most important? The most important is that I am not going back to any server outside the machine to deliver my information. It's not like Siri or like the News. I don't need to deliver. I don't need anything to deliver information. And this is what we call edge computing. Edge computing means taking the artificial intelligence to the peripheral sides of the planet. So I can have artificial intelligence dedicated spot, autonomous spot, directly in my machine with really inexpensive components. Okay. So what is the price of this thing? Well, you have to pay the computer scientist. That's the problem. I am eating a lot, and that's where your money is going to fit. But if you think about components, they are really commonly available, they are really reliable. I can stay here. This thing is going to live from minus 40 to 170 degrees if you don't consider the box. Okay, so it is an industrial component. And there's something else very interesting. When I see a human, this little light is turning on. It seems something very stupid. If I do like this, the light is not turning on. But as soon as I see a human, or an end of a human, the light turns on. See? The other interesting thing is that this thing is able to recognize a particle. It doesn't need to see a whole human. It is able to recognize a part of a human. So it will be able to recognize a part of an atom. Okay, once this is trained, for example, for the quality cycle of your machine, then if something goes wrong, it will be able to recognize the going wrong from a part of the going wrong. And this is what this technology can do for us. Okay, so this is something that we really need to focus. Okay. Sensors are very commonly available on the market nowadays also. I mean, they're very expensive, built up in sensor. I've been able to build up yesterday evening in the open. I've been able to build up this thing, which we will use in the next, because I didn't have one. This is a spectrum analyzer. I have built it up in I've stolen some pieces from the sensors, which we generally use for predictive maintenance, and I have built up this thing in a quarter of an hour. So, I mean, we have all the ingredients for the revolution. The point is, find the application and make it happen. And that's it. So, I hope that you have got not bored, as it was possible. I hope that you have got inspired. And that was my speech. Thank you very much for being here. If you have any question, I am available.